Okay, let's talk about C++ pointers. This is always a hard topic to talk about because it scares so many people. And depending on whether or not you learned it in C before you got to C++, it's pretty much where that fear comes from. Maybe this was something you learned at the end and it was a really hard concept for you to grasp, or maybe you just didn't get it. So, and for those of you who took in Java, you've never seen a pointer. So, I'm going to go ahead and try to do a step-by-step process here and I'm probably going to break this up into two videos. This first video is going to cover the basics of pointers, and then I'm going to go into do more advanced topics in another video. So let's take a look at what I have here. At the beginning, you'll notice that I declare an int. And this is pretty common. It did it pretty well. So if you read this, it'll give you a good something to look back on. So I declare an int and I give it a value of 5. After I do that, I declare a pointer, and a pointer looks like this. It's an integer pointer because I'm going to deal with all ints in this program, and I call it my ref address. And it has a star on top of it, and that star makes it a pointer. This represents that my address now points to an int. Okay, so all that means is that this is an integer pointer that I declared. Okay, and I didn't do anything with it yet, just declared an integer pointer. Hopefully that didn't scare anybody. Now the next thing is that I use, now this is the name of the pointer, my ref address. I'm going to break it down into a couple steps here. My ref address, I'm going to go ahead and assign it my int, but not the value of 5. I'm going to use this ampersand sign, and what that does is it's going to reference the memory address of my int. So not the value 5, I'm going to get the hex code memory address of my int. So now, and it's going to store that hex code value inside of my address, right? My ref address. So the memory location is now stored in my ref address. Okay, so far so good. It didn't get the 5, it got some kind of hex code, and it's inside of my ref address. Okay. Now, I'm going to use this pointer thing now. So, this didn't have a pointer thing, this does. So, this pointer thing, my ref address, what's it going to do? It's going to take this address that it's stored over here by getting the address of my int, and now it's going to use the pointer feature of it, and it's going to assign the value 10 to that memory location it's stored in the line previously. Okay, follow me so far? So it's going to update the memory address that it stored, which it stored the memory address here, and put the new value at that address. So the new value that's going to go at that memory address is 10. Now remember, that memory address had a value of 5 in it. So I accessed that memory address and put this 10 inside of it. Okay, which means that logically, since I updated that memory address with the value of 10, and therefore my int, when it accesses that memory address again, it's not going to pull 5, it's going to pull 10, right? Exactly. So when I print this line, see out my int and line, you'll notice that my int has a new value because the address it's referencing has an updated value, which I did. I put a 10 there. So this will print 10 instead of 5. Okay, let's go back through it again. I declared this pointer. I have the pointer, but I didn't use the pointer yet. I just used a regular variable name, and I assigned it the memory address of my int by using this ampersand. Not the value, just the memory location, where it's at. And then I used the pointer, the feature of my ref address, and I use that pointer to update that address that it got right here with this value, 10. Okay. Now a shortcut way of doing this, and this is what you'll see most commonly, is that the pointer was declared right here, just like it did, but then it gets the memory address right here as well. So now it knows right away the shortcut way of doing this and this together was this line right here, by giving that pointer the memory address already to be pointing to. Okay, so this gets clearer if we had a little picture here, which I don't, which is the memory address of my ref address and the memory address of my int now point to the same location in memory. Right. So just keep on going through this tutorial a couple times and then just listen to what I say, and it should be able to stick after all, maybe, I don't know, 30 times of watching this video. But keep on, it's well commented here, and even if you just turn off my voice and just keeps on reading this should help you. Okay. Alright, now that we got that taken care of, let's look at something else. Oh, you must be saying, that's mind-blowing. I don't really want to look at anything else. But, well, we have to. So, I'm going to declare another int variable. I'm going to call it int total gets 15. And right here, you'll notice I use that ampersand again. What this does is I'm going to declare a variable called sum. But I'm going to use an int ampersand. And what this is going to do is going to make sum and total reference the same place in memory. Alright, so this is a little bit different from what we were doing up there. Alright, I should have put like some dot 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 lines across or something. But essentially, it's going to call total by a different name called sum. So sum and total now reference the same place in memory. So if they both reference the same place in memory, when you change sum, say 18, total gets updated with 18. If you change total with 21, sum gets updated with 21. You don't believe me? Well, let's go ahead and run all of this together. Let's see. Alright, this 10 represents this cout my int. When I already had my int as 5, down here when I print it out after I created a pointer and accessed the memory location and put a 10 in it, you'll notice that it proves that 10 now was printed when you printed my int, because they both reference the same location in memory. Now down here I had a 15 which was total, and then I made a int ampersand, which means that sum and total now reference the same place in memory. When I updated sum to 18, remember, not total, I updated sum, and I printed total right after it, it printed 18, because when you change sum, total gets updated. And if you go down here, and you'll notice that when I updated total to 21, I printed sum directly after it, not total. I printed sum, and it also shows 21, because when you updated total, total now changes sum as well. So they both reference the same place in memory. So no matter what you do, when you call on each other, they'll be the same thing. I hope this was helpful, and watch this tutorial over and over again to give you a better handle on pointers. And this is just part 1, guys and girls. We'll be doing part 2 with a little bit more complicated pointer, especially when you get into functions. Okay, I will see you in the next video.